Hello everyone, today we are going to demonstrate another tutorial which is on Allowance dApp, which will specify the importance of the intercontract calls. This particular Allowance dApp will demonstrate the integration of two smart contracts. One is the role contract, then the another one is the allowance contract. Role contract will focus on the role based access control, and the allowance contract will focus on the fund management. It will highlight the importance of intercontract calls and how intercontract calls works on the ELF blockchain, where we will use the allowance logic to depend on the roles retrieved dynamically from the role contract. The purpose of this dApp is to teach the access control and the inter smart contract calls on the ELF blockchain. In this particular tutorial, we will complete this tutorial in multiple steps. In first step, we will set up the local development environment where the developer should have basic knowledge of terminal commands. If you have installed an IDE, then you can use that IDE. Otherwise, you can install VS Code using this link. Then you have .NET 8 SDK. If you haven't installed .NET 8 SDK already on your system, so you can install it by clicking on this link. Then in the next step, we will install the ELF contract templates. ELF contract templates can be installed using .NET new hyphen installed elf.contract templates command. We will copy this command and we will paste it inside the terminal to install the ELF contract templates. This will install the ELF contract templates. If ELF contract templates are already installed, then it will check the version, and if it is the updated version, then it will reinstall it. Now the ELF contract templates are installed again. ELF contract templates contains various predefined templates for the ease of developing smart contracts on the ELF blockchain. In the next step, we will install the ELF deploy tool. We will copy the next command, which is .NET tool install global elf.deploy. So now we are installing elf deploy tool using this command. It will install the elf deploy tool. Elf deploy tool is the utility tool for deploying smart contracts on the ELF blockchain. Once you install the elf deploy tool, so you'll have to export the path using this command. So you need to export the path to install the deploy. Now you should also install Node.js and Yarn. If you haven't installed Node.js yet, you can click on this link and you can install it in your system. Then you can install Yarn by clicking on this link, and it will install Yarn on your system using the npm command. As I have already installed these two, I will move to the next steps. Now I need to install elf command. ELF command is a CLI tool for interacting with the ELF blockchain, enabling tasks like creating wallet and managing transactions. Now we will install the ELF command using this command sudo npm install -g elf command. If the sudo permission is required, you need to enter the password of your system. Once this is installed, it will install the ELF command on your system. So this will complete our first step of setting up the development environment for a tutorial. Now, as we have completed the first step, now we are going to develop the role smart contract. The role smart contract will contain the logic for setting the roles. So now we will first create a directory, that is role contract, using the command mkdir, and then we will change to that directory. So first we will use this command to create a new directory, and then we will change to this directory. Now we need to create a new template for the role contract. So we will copy the next command that will create a new template for the role contract using .NET new elf. Now a new template is getting ready for the role contract. Now we will add the smart contract code to the role contract template. So we can customize it to implement role-based permissions for the various use cases. Below are the functionalities which will be used in this role contract. So first functionality is the set admin functionality, and set that will allow the admin to set the new admin address. Then we will have set parent and set child functions to set the parent address and set the child address. There will be a condition on setting the parent and child address that only parent can change the parent address and only parent can change the child address. Then we have retrieve functions to retrieve the addresses for all admin, parent and child. Role-based access control will ensure that only admin or parent can assign roles using the access validation logic. Now, as we have created this template, so now we can open this project inside our IDE, that is VS Code. We will open the project in our IDE. Let's open our project in the VS Code. So now we have created this inside role contract. So we will open the role contract here. Now, as we can see that the template has been created for the role contract. Here we will see a protobuf folder along with role contract files for the smart contract. Now we'll open the terminal here itself. Now we will write the logic for the role contract. So first we need to change the name of the protobuf file from the hello world contract.proto to rolecontract.proto. We'll copy this name. We'll go back to our IDE. There inside protobuf and inside contract folder, there is a file called hello world contract.proto, and we will rename that file to rolecontract.proto. Once the file is renamed, then we can copy the code for the proto file for the role contract. Now we'll copy the code and we will go back and we will paste this code here in rolecontract.proto. We'll select the existing code and we will delete it and we will paste the code which we just copied and we'll save the file. In the next step, we will define the contract state. Now, the RPC methods and messages defined in the proto file, here you can see there are some RPC methods defined. For example, set admin, set parent, set child and get child. These are the functions required to set and get the admin, parent and the child. There is one other function that is initialize, that is used to initialize the smart contract. Now, in the next step, we will define the contract states. While defining the contract state, we will go inside source folder. There is a file called rolecontractstate.cs. We will copy the code in the next step and we will go to this file and we will select the existing code, delete it and we'll paste the copied code and we'll save the file. Now, the state file on the aelf blockchain smart contract holds the variables that stores the contract's data, making sure this data is saved and accessible whenever the contract needs it. Now we will implement the actual logic of the whole smart contract. So now we will simply complete the functions. So proto file contains the definition of all the functions of the smart contract, and this particular file, or you can say this smart contract file, will contain the logic of all the functions which we have defined inside the proto file. So now we'll go inside source folder. There is a file called rolecontract.cs. We'll copy this code and we will go to this file. We will select the existing code and we will paste the code which we just copied and we'll save the file. Now we'll understand the functions which we have written. So there is a default admin address which you can provide, where you can write your portkey address. Portkey is a aelf blockchain wallet which we have covered in another tutorials as well. Then there is a function, that is initialize function, which initialize the state of the smart contract. Then there is a function to set the admin, parent and the child with some conditions like assert is admin and assert is admin or parent. It means these are some helper functions which defines that if we use assert is admin, it means that only admin can change the address. And then if we use the another helper function, that is assert is admin on parent, it means either admin or the parent can change the address. Now we have setter functions, then we have getter functions to get the addresses of the admin, parent and the child. Now, as we have completed the implementation of the role contract, we will now build the role contract. So we'll copy the next command to build the role contract. We'll copy this command, we'll go back to our terminal, then we will go to the source folder inside terminal by using the command cd src, and then we will paste this command, that is .NET build. Now it will build the smart contract which we have just written, and this step will create a bin folder, and inside bin folder there is a debug folder, and inside that there is a net6 folder, and there you will see a file with .dll.patched extension. It means your build was successful and you have created a .dll.patched file which will be used in the next steps. Now we will deploy the built contract. So now to deploy the contract, we need an account or we need a wallet. So we will create a wallet first. So using elf command, we can create a new wallet. A wallet will contain the private key and the public key, dynamic and the address. So now first we will copy the command, that is elf command create. We will go back to our terminal and we'll paste this command. It will create a new wallet for me. Now it is asking me to save the information of my wallet to a file. Now it is asking me for a password to save this information in a file. Now we'll provide the password to encrypt this information in a file. Now this information is saved in a file. It means our wallet information has been saved in a file. There are four things which are the output of this particular step. One is the nomic, one is the private key, then the public key, then the address. Public private key pair is the identity of any user on a blockchain, and nomic is a derived form of the private key, and address is a derived form of the public key. We will use these informations in the next step. Now, as we have created a wallet password to encrypt the information, so we will export that. Now we will export the next environment variable, that is wallet password. We'll go back to our terminal. The password which I chose in the next step to encrypt the information was elf@123. I will export this wallet password. Now, in the next step, I will export the wallet address as well. The address was generated in the first step where we use the command elf command create. Here we have this address. We will copy this address and we will set another environment variable, that is wallet address. Now we will first get some tokens to simply get the tokens to deploy the smart contract. So on blockchain, you need some tokens to deploy the smart contract. Now to get some tokens, we will copy the next command, that is curl command, and we will go to our IDE and will paste this command. I have pasted this command here, and there you will see is success true. It means that you have successfully gotten the tokens. Now we will go to the next step to check the balance whether we got tokens successfully from the faucet or not. So now we will copy the next command to check the balance. So we'll copy this command. We will again go back to our terminal and we'll paste this command. So this command contains the address of the multi-token contract which handles all the tokens on the ELF blockchain, and it requires the wallet information, that is wallet address and password, and then it checks the balance on the test node, and then it uses the function, that is get balance. Now we will check the balance. In this, we need to check the balance of a token, and the token which is in question here is ELF token. So it is asking for a symbol for ELF token is ELF, and it is asking for a owner. So the owner is this address. Now we will paste this address here, and then it will fetch the balance, and here you can see the balance is greater than 0. It means that we have successfully gotten the tokens from the faucet. Now we'll move to the next step where we will deploy our smart contract. Before deploying our smart contract, we need to set another environment variable, that is to export the contract path. Now in the build step, we actually created a .dll.patched file. We will copy the path of that file inside this contract path environment variable. Now we'll copy this command and we'll paste this command here, and it will set the contract path of this RoleContract.dll.patched file here inside this environment variable. Now we are going to deploy our smart contract using the elf deploy command. Here in this command, elf deploy, it uses the wallet information and the contract path which we are trying to deploy and on which network we are trying to deploy. This is the network URL. We will copy the next command and we will again go to the terminal and then it will deploy the smart contract. If you face a similar issue where you see command not found elf deploy, in that case you can uninstall and reinstall the elf deploy tool. We will go back and copy the command to reinstall the elf deploy tool. You can copy the command to install the elf deploy tool from the first step, that is setting up the development environment. Now first we will uninstall it using the uninstall command and then we will install it using the install command. Please do not forget to set the path, or you can say export the path once the elf deploy installation runs successfully. As we can see, elf deploy was successfully installed. Now we will export the path using the export path command. Now we have successfully installed the elf deploy tool again. Now we will try to deploy the smart contract again. Now the deployment process has started. Deployment process takes some times. It will initially provide some proposal ID to the deployment, and then every deployment is also a transaction. So we will also get a unique transaction ID and then it will deploy the smart contract on the ELF blockchain. Deployment means our smart contract code gets stored on the ELF blockchain. As you can see, a proposal ID has already been assigned and deployment process is also a transaction. So it will take some time to get this transaction added to a new block. Once this transaction is added to a new block, it means the smart contract will be deployed on the ELF blockchain and it will provide a unique identity of the smart contract. That is the smart contract address which we will get after the deployment process ends. As we can see, the deployment process has been completed and we got one address, that is our smart contract address, which we will use in the next steps. Now, as we have successfully deployed our smart contract, we will move to the next steps, that is to develop the allowance smart contract. Please remember that allowance smart contract will make the inter-contract calls to the role contract. We are emphasizing on the role of the inter-contract calls on the ELF blockchain inside the smart contract. For this, we first need to create the allowance contract directory. So we'll use the mkdir command and then we will go inside that directory and then we will create a new template for the allowance contract. Let's open the terminal and make the allowance contract directory. But first we need to change the directory from the role contract. So first we will go to the parent directory and then we will create one more directory, that is allowance contract. Now we will change the directory to allowance contract and now we will create a new template, that is allowance contract template, and we will paste this command here. Now the template has been successfully created. So now we will add our smart contract code to the allowance contract template which we just created. In the allowance contract, there is function that is to set the allowance. So a parent will be able to set the allowance for a child and the role of the parent and the child will be fetched from the role contract. So it means the allowance contract will make an inter-contract call to the role contract to fetch the roles of the parent and child so that a parent can set an allowance for a child. Then there is a function to use the funds. So it will allow a child to spend the funds and it will fetch the child address from the role contract. It also has the get allowance function which retrieves the remaining allowance for the child from a parent. Now, as we are saying that there is a role based permission, it means the parents are able to set the allowance for the child and the roles will be fetched from the smart contract. As we are emphasizing on the inter-contract calls, so this contract will showcase the inter-contract calls and will show a role-based fund management demonstrating how multiple smart contracts can work together for secure, controlled, and financial operations on the ELF blockchain. It will also help in understanding how the allowance contract calls the role contract to check which sender, or you can say which role, is getting fetched and which role is making the call for a function in the allowance contract. So now, first we will open this particular template of the allowance contract inside the IDE, that is VS Code, and we will go inside the source folder. So now we will open the VS Code. So we will open a new folder, that is the allowance contract. So now we'll open this particular template, and here we can see there is a template where again you will see a protobuf folder as the files of the allowance contract we can see here, and the folders as well inside the protobuf folder. So now we are going to develop the smart contract. So now in the first step we are going to rename the hello world contract.proto inside protobuf and contract folder. So we will use this name to rename the hello world contract.proto here, and we will rename this file first. Now after renaming, we need to update the logic because the proto file contains the method definition. So now we will add only the definition of the methods which are part of the allowance contract. So now this is the proto file for the allowance contract. Here we have the definition of the initialize function or method, and then set allowance method, get allowance method, use funds method, and if initialized is a helper function which helps in checking whether the contract is initialized or not. And these are only the definition of all these RPC methods. So now we are going to copy this particular proto file, and we are going to select the existing content and delete it, and we'll paste the copied content and we'll save the allowance contact.proto file. In the next step, we will actually define the contract state for the allowance contract. So now there are multiple states like admin address, parent address, child address, and current allowance, which we uses in the smart contract. Now we will go inside the source folder where allowance contract state.cs file is there. We will copy this code for the state file. Now we'll select the existing code and we'll paste the updated state file, and we'll save this file. Now in the next step, we are going to implement the allowance smart contract logic. So now logic means the functions or the methods which we have defined inside the proto file. We will simply implement those methods. So here is the implementation of set allowance method, then get allowance method, then use funds method, and the if initialized function implementation is also there, and the initialize function implementation is also there. Now set allowance function helps in setting the allowance for a child from the parent, and it checks who is actually making this call, and it sets the allowance for the child. Then get allowance fetches the allowance for the child, and use funds means the child can use the allowance provided by the parent, and then if it initialized actually helps in checking the status of the smart contract whether it is initialized or not, and initialize helps in initializing the smart contract. First we'll copy the code, and then we will go to the allowance contract.cs file inside the source folder, select the code, and we'll paste this and we'll save this file. Now we have written the logic for our allowance contract, and we need to provide our role contract address here before deploying the smart contract. Now as we need the role contract address, so we can deploy the role contract again here using this command. Now it will start to deploy again, and once we get the address, then we can use that address as the role contract address. As we can see that the role contract has been deployed successfully. Now we will copy this address, we will go to the allowance contract, and we will paste this address here. We'll save this file. Now as we have written the logic, now if we see in the set allowance function, here we are calling the role contract and calling the function of the role contract, that is get parent, right? So now to call this role contract, we need to create the reference for that, or to make the inter-contract calls from the allowance contract to the role contract, we need to create the references. Now, how we will create these references is to by creating or generating or using the role contract.proto file. So we'll use this file and from the role contract in the allowance contract. So we will copy this file. So now first we will go to the role contract and we will copy the proto file of the role contract. Then we will go to the allowance contract, and inside the reference folder we will paste this file. Now in the next step we need to manage the states as well. So now we will manage the states. So inside the allowance contract folder itself, so we'll need to create a new file, that is contract references.cs. So which will manage the inter contract states. So now simply I will copy the name and then I will create this file inside the source folder. So please make sure that you create this file inside the source folder, and in this we will generate or create the reference from the allowance contract to the role contract. So now we'll paste this here and we'll save this file. So now this completes the logic where now, as you can see, we are actually dealing with the allowance contract namespace and the class, but we are actually using the content container and the reference state of the role contract. So now this role contract state will be used inside the allowance contract. Also, we created a reference using the role contract.proto file which we used here. And now if we see the logic of the set allowance function, which is calling the role contract, so now role contract becomes a state. So now we can use that state, and inside that state there is a function called get parent inside the role contract, which we can call from the allowance contract. So now this completes the implementation of the allowance contract. Now as the implementation has completed, so now we will build this smart contract. Now to build this smart contract, we will write the command .NET build inside the source folder, and it will build the smart contract. So the build process will generate the bin folder and will also generate the debug folder and net6 folder, and inside that you will see a .dll.pest file. Now, as the build process was successful, in the next step, we are going to deploy this allowance smart contract. So again, we need to, as we are in a different terminal, so let's create a new account and then let's deploy the allowance contract. So I will skip directly to the deployment step, as we have already created the account and we have already gotten the tokens from the faucet. You can repeat it inside the other terminal, but please make sure that the paths are correctly set. Now, so let's move to the deploy step of the allowance contract. So I'll copy this deploy command and I will paste it here to deploy the smart contract. And now it will deploy the allowance smart contract. So again, it will take some time to deploy the smart contract. So it is a transaction. So initially we get the transaction ID and then we get the proposal ID. And once the smart contract is deployed, then we will get the deployed smart contract address. So it will take some time to deploy the smart contract. Now, as we can see, the smart contract for the allowance contract has been deployed to the aelf blockchain, and this is the smart contract address we got for the deployment. Now we will move to the next step where we will develop the front end to interact with our deployed smart contracts. So now we will make the application and then we will interact with the smart contract using that application. So for that, first we need to clone the GitHub repository, that is aelf samples. Now let's clone the GitHub repo for the aelf samples. Now we will paste this link inside the terminal to clone the aelf samples, and then we will open aelf samples inside the VS Code. Let's open VS Code and open the folder that is aelf samples, which we just cloned. So this is aelf samples. Now here we can see here is an allowance app and there is a 2dApp folder. Inside that there is a React application for the allowance dApp, which is a template for the front end application for the allowance dApp. Now we will open the terminal. First we will install the packages which are necessary. So first we will go inside the allowance folder. Then there is a 2dApp folder inside that, and there we will run the npm install command to install on the all the necessary packages. When we provide sudo, we need to provide the password as well. So now we will go to the next steps. Here we can see, like, we could see the project structure and we have installed the necessary libraries. Now in the next step, we are going to configure the port key provider. Port key is a wallet on the aelf blockchain, which is going to help to interact with the smart contracts from the application, or you can say from the front end application. So now We'll write the connect wallet function as well after configuring the provider. So the browser provides a provider, and then that connects with the application that we call as connection of the wallet with the application. So now in the first step, we will go inside source hooks folder, and there is a use smart contract.ts file, and we need to find step A, that is function to fetch a smart contract based on deployed wallet address. So now we will copy the next code sample. So this code will fetch the contract. So first it will get the chain, that is the test net main chain, and then it will get the contract based on the address we provide. So now first we will copy this, and then we will go to the step A inside source hooks, and then source hooks use smart contract.ts file step A. So now there is an incomplete implementation of the fetch contract function. So now we will paste the complete implementation which we just copied, and we will save the file. In the next step, we will go to step B, that is to fetch the role contract. So initially now, as in this step, we have connected the wallet, or you can say we have connected the provider, that is portkey provider. And now we are going to fetch the role contract. So now first we will copy this code, that is for the step B. And here you can see like we need to provide our deployed role smart contract address here to fetch the smart contract from the blockchain inside the application. So we'll copy this code, and we'll go to step B, and here we will go to step B, and we will complete this function, that is get role contract, and it is going to fetch the smart contract for us. So now I'll paste this code, and here we need to provide the role contract address. Now we are going to paste the role contract address here. So I have copied and pasted the role contract address here. Now we'll go to step C, that is to fetch the allowance contract, and we will write the function, that is get allowance contract. We will copy this code sample, and we will go to the next step. Now we will copy the step C, and then we will complete the step C here, that is to fetch the allowance contract. Now here I will complete the implementation, and here again I need to provide the deployed allowance smart contract address. For convenience, I have kept this address here. So I'll copy this and I'll paste this address here, and now I'll save this file. Now in the next step, I need to implement the hook to call these two functions, that is to fetch the allowance contract and fetch the role contract. So now fetch contract functions are checking the providers, then it is fetching the chain, and then getting the contract. And the contracts are role contract and allowance contract. So now I will implement the hook to call these functions. So now I will use the use effect hook, and I will go to step D to implement the hook. And here this is the incomplete implementation of the hook, and I will copy the step D, and I will complete the implementation here, and I will paste the code and save this file. Now in the next step, we are going to configure the connect wallet function. So to configure the connect wallet function, we'll go to step E, which will implement the connect function. Now we will copy the code sample. Let's implement this functionality. Now we'll need to go to the file that is inside the header, that is index.tsx, and we will go from source folder to components to layout, and inside header we will find the index file. So we go to source, then components, then we will go to the head layout, and then header, and there is an index file. Now here we will find the step E, that is the connect function, and we will replicate the implementation which we just copied for the connect wallet function. So this function is going to help in connection of the portkey wallet from the portkey provider, and then it will fetch the accounts from that. Now in the next step, we are going to configure the set admin role. So we wrote the role contract where there is a function that is set admin role. Now we need to call this from the front end. So we are going to create a form for that. So now we'll go to step F inside the home page, inside the pages folder. So we'll go to step F to configure the role form. Now let's go inside source, then pages, then home, then there is an index file, and we'll go to step F, that is to configure the form here. And now we will replicate the implementation, and we will save this file. Now In the next step, we are going to simply initialize the contract and set the default admin address. In the last step, the field which includes is the address. It means while uh, accessing the form, we are going to provide one field, that is the address field. So now to initialize the role contract, we need to write the step G. So this step will initialize the role contract simply. So it will call the initialize function of the role contract to initialize the state, or you can say to change the state of the role contract. So we'll copy this code sample. So what this code does is it calls the role contract, and inside that it calls the initialize function, and then it gives a notification that whether the contract was initialized successfully or not, and then it simply gives the notification if there is any error. So now we will copy this code, and then we will go to step G, that is inside the same file. So now we'll go to step G. So we'll find step G here. Here is the step G to initialize the role contract, and we will paste the code here and we'll save this file again. Now this function, as I explained, is going to initialize the role contract. Now we are going to set the admin role. It means we are going to call the role contracts set admin role function. Now set authority is the function name, and it will set the different user roles. So we have written the if else statement. So here we are going to again call the role contract, where we will call different methods like set admin, set parent, set child, and whatever we call, we are going to then update the role accordingly, or we are going to update the address accordingly for all these methods. And then we are going to provide a notification, and then we will fetch the authority data, and it will then catch the error if there is any and will show the notification, and then it will remove the notification as well when the time is over. So now we are going to copy this code sample, and we are going to go to step H. This is to set the user roles. We are going to set all user roles with this function, and we will paste this code here. Now, in the next step, we are going to submit the form. So we created the form. Now we need to submit this form as well. It means when a button will be clicked to set the admin or to set the parent, or simply a form button is clicked, then how we are going to handle that? So we are going to write the on submit function, which will handle the click of the button, and it will then will check the initialization status, and then we'll call the set authority function. So we'll copy this, and we'll go to step I, that is to handle the submit form, and we'll paste it here, and we will save the file. Now again, now we are going to get the roles as well. So we are going to fetch this role details inside our, you can say, application. We will fetch the admin address as well, we will fetch the parent address, and we will fetch the child address as well, based on the fetch button clicked, or based on the fetch data we need on the screen. So now we are going to fetch these details, and then we are going to set these data on the screen, and if there is any error, we are going to show the error inside the console. So we'll copy this code sample again, and then this function is get authority data, which was again used in the set authority as well. So it simply fetches the data when it is already set. So now we'll go to step J. So the step J is the next step to get the role data. Now we'll go to step J. So this is the step J, that is the get authority data function. So we are going to complete the implementation of this function. So now we are going to copy this code sample, and then we will complete the implementation of get authority data function. We will save the file. Now this function is again calling the smart contract methods and then fetching the roles. Now as we have set the roles and fetched the roles, now we, based on the roles, we can set the allowance as well. So the parent can set an allowance for a child. So it means it will be an intercontract call, which we explained in the contracts. On the front end, it will be a simple front end integration where the parent address should be connected to set the allowance for a child. So now we'll go to step K to configure the set allowance. So now we will again create a form to provide the allowance, and inside form we need to provide the amount for the allowance. So now we will create this form. So we will copy this code, and we will go to step K inside source component parent folder. There is an index file. source component, and then there is a parent folder, and here is a step A, and we are going to configure this form. So we'll paste this code here and we'll save this file. Now what this does is it is simply configuring the form to pass the amount. Now we will check the initialization status of the allowance contract, whether it is initialized already or not. So now we will go to step L, where we are going to call the if initial is initialized function of the smart contract. If initialized function of the smart contract, which checks whether the smart contract is initialized or not, which we have explained in the smart contract development section. And then based on the result, it sets the state of the initialization status. So now we will go to step L to check the status of the allowance contract. So step L, and we will complete the implementation of step L here itself, where we will paste this code. Now in the next step, we are going to initialize the allowance contract. Let's say, for example, if the allowance contract is not initialized yet, so we are going to initialize that. So for that, we are going to call the allowance contract, and there is an initialize function inside that. And if the initialization is successful, we are going to show a notification and set the state as true. Now let's initialize the smart contract. So we'll copy this code. We'll go to step M, and we will complete the implementation here. We'll save this file, and then we'll go to step N, where we will actually set the allowance, where we are going to call the set allowance function of the allowance smart contract. And then once the allowance is set, then we will fetch the updated allowance, and then we will show a notification that the set allowance function was running successfully. And then we will show a notification if there is any error. So we'll go to step N, and here we are going to paste the implementation, and then we are going to next step, that is to submit this form. So there is a on submit button, so we are going to now submit the form, where first it will check the initialization status, and then it will call the set allowance function. So now we'll go to step O, and then we will complete the on submit function. Then we'll go to the next step, that is to get allowance value, that is step P. So we'll call the get allowance function for that, and inside that we are calling the allowance contract, and the function call is the get allowance. And then we will simply copy this and then call this function in the step P, where we will fetch allowance or get the allowance, and we will save this file. This step simply completes the implementation for the parent component, as the parent has already set the allowance and provided the allowance to child. So now the child can simply configure the spend allowance form, or you can simply say the child can simply spend the amount provided by the parent or allowed by the parent. So now we will configure a form to spend the allowance. So first we will copy this form, and we'll go to step Q. Here we'll go to step Q to configure the spend allowance form. So we'll have to go to the child component, and there we need to find the step Q to configure the form, and we will configure the form here, and then we will fix this form. In the next step, we are going to go to the get allowance value. So now child also needs to fetch the value for the allowance. So here we will fetch the allowance value. So we will call the allowance contract, and there is a function called get allowance to fetch the allowance value for the child address. So we'll complete the step R, where we will implement the get allowance function. And now in the next step, we are going to implement the spend funds function, where the front end will call the allowance contract itself again, and here it will check whether the allowance value which is set is less than or greater than the amount requested by the child. So amount should be less than the allowed amount, and then the allowance contract will be called, where the use funds function will be called, and then it will set the allowance again after the funds has been used. So for example, if 10 was allowed and 5 was used, so now it will update the remaining allowance as 5, and then it will show us the notification. So we'll go to step S to spend allowance function, that is step S. So we will complete the implementation of this function. We will save this, and now we are going to go to the next step, that is to like simply submit this form. So now we need to configure the button where we will call the spend funds function. And now we'll go to step T to implement this, and we will complete the implementation of this spend function. So now we have completed the implementation of the front end, where initially we configured the portkey provider, then we connected the portkey wallet with the application we are making, that is the front end application. Then after that we connected with the role contract. So initially we fetched both the contracts, that is the role and allowance contract which we created earlier, and then after that we simply updated the addresses, that is admin, parent and child addresses, and then we fetch those values, and then later on we go on to interact with the allowance contract, where we interacted with the set allowance, get allowance and spend funds function, and we also use the initialized and if initialized functions as well of the allowance contract. So now as the front end implementation is complete, we are going to run the application. So copy the next command. You can use the sudo privilege to simply avoid the access issues. And then you are going to run this. Sudo requires the password and we will run this application. So this will run on the local host. If the port is busy, 5173 is busy, it will run on 5174. And if it is not, then it will run on 5173 port. So now let's open this port. Now let's open this port or URL on this port where our application is running. So we'll open this. So now it gives an option to connect the portkey wallet. So now I will connect my portkey wallet. So I'll unlock this, and it will now show the details. So now it is showing the admin address already, as we can verify that this is my portkey address. So this is my portkey address. So that's why it is showing. So it means it was already configured in the role contract. So now the set parent and set child functions are there. So now admin can simply set the parent address and child address. So now we will set the parent address first. So we will configure like inside this form, we will provide the address of the parent, and then the parent will be like visible, or you can say the parent address will be set after calling the set parent function. Now we will set the parent. So we have the parent address now, and we will call the set parent function from here. And now as the admin is calling this function, so we will sign this transaction, and now it will set the parent address. So now we are calling the set parent function. Now the set parent is successful, and we can see that the parent address has been successfully updated. So now we can set the child as well, and we can edit the parent address from here also. So now we will set the child also. So we will set the child address from here. We will paste this, and then we will set the child. It will call the set child function of the allowance contract, and we will sign the transaction, and it will set the child address as well. And we can see it has set the child address and parent address, and we can edit these as well. So now all the admin functionalities are complete, that we are able to set all the addresses like admin, parent and child, and we can update them as well. Completed the admin functionality. So now we will connect with the portkey wallet of the parent. So now I have configured portkey for the parent, and now I can see the address for parent is this, and then I can see the child address as well. As I haven't set the allowance already for the child, so it is showing no value here. So now I will set the allowance for the child. So now let's say I set the allowance as 100 or 1000. I'll click on set allowance, and it will call the smart contract function. I'll sign this transaction, and this function call will be made from the parent, and then it will simply first initialize the allowance contract, and then we'll set the allowance as 1000. We can see the allowance is 1000, and parent can simply edit again. So it will again call the set allowance function and will edit the allowance value. So now the parent has set the allowance, and we are able to see that we are able to fetch the allowance as well. So now we will go to the child portkey address, and from the child we will see that how child can use this allowance and spend the funds allowed by the parent. So now I will configure the portkey wallet of the child. So we'll connect the portkey wallet of child address here now. So let's disconnect this one. You can exit the wallet like this, and then I will be using an email to log in for the child. So let's say this is the email I am using. And now I can log in through the OTP sent on this email. Now I have gotten the OTP, so I will verify the user here, and it will connect the portkey wallet, or you can say it will simply log in the portkey wallet of the child. So this is the child address, as we will see as well. So now we will connect the child wallet here. So first we will refresh this and we will connect the wallet of the child. So I will approve this connection, and this is the child address which we set, and I can see the allowance is 1000. Let's say the child spends 500 from this. So the child will click on the spend button and it will call the use funds function in the smart contract, and the child will sign this transaction. So now the child is calling the use fund function, and now the allowance is also updated. So it means that the child could successfully spend the funds from the parent, allowed from the parent. So this particular tutorial mostly focused on how we can or how we could fetch the roles from the role contract. It means how we could make the intercontract calls, and then how we could set an allowance for the child based on the role, based on the parent role, and how the child can simply spend that allowed amount. You follow difficulty in the steps we just followed, you can follow the documentation here where it is showcased that how you can simply add the portkey wallet in your browser. It is recommended that you use the Chrome browser, and then you can add the Chrome extension, and then you can get some tokens from the faucet, and then there is the connect wallet functionality which is showcased here, and then we connect based on the role. So first we connect for the admin where admin can set the roles, and then the simply the set admin call function, then set parent function. So how we call the smart contract, and then there is a set parent and set child functionality, and how we can add these roles as well. And then there is a set allowance function which the parent calls, and it is the parent screen where the parent can call the set allowance function and fetch that allowance. And then there is a child screen where the child can simply see the allowance and also spend the allowance which is allowed to the child. So now at this step we have concluded this tutorial. Consisted of multiple steps where initially we set up the development environment, then we develop the smart contract, one for the role contract and one for the allowance contract, and then after that we showcased the importance and the flow of the intercontract calls where we called the role contract from the allowance contract. And this tutorial mostly was emphasizing on the intercontract calls and how it can be made inside ELF blockchain or ELF smart contracts. Then we deployed both our smart contracts. One is the role contract, one is the allowance contract. And in the allowance contract, we set up the intercontract calls where we created a contract reference and we provided the proto file of the cold contract, that is the role contract. So we provided that file inside the allowance contract, and then we simply created a front end, that is the application, decentralized application, to simply interact with both the smart contracts from a single platform. And if you want to simply modify it, if you want to make it more generic or more complex application, you can modify the logic to implement for multiple parents and multiple childs, and also modify the logic on how more intercontract calls can be made. And then you can simply define your own logic as well, and enhance the smart contracts. So this was about the Allowance dApp and the intercontract calls on the ELF blockchain. Thanks for tuning in. Keep watching the tutorials and keep learning on the ELF blockchain. Thank you.